क्रिएटिव चैनल्स को और बेल आइकन को भी प्रेस कर दीजिए जिससे आप अपडेट रहे हमारे हर वीडियो से।
Hello friends, hi, you are watching my channel. The name of my channel is Creative Help and thank you for watching my channel. My name is Muhammad Amir Salam. I'm by professional engineer. I have done my BTech from Jamia Millia Islamia and I have more than 6 years in HVAC experience. So today we are going to read about the VRV system. So what is the VRV system? The introduction is like that. So VRV system is the flow of like the flow of refrigerant as per the demand. So we know about the, if you are just we are going to introduce in an interview, they will ask the what is the full form of the VRV system. This is the full form of the VRV system is like that. So refrigerant flow. Okay, so system vary from the flow of the refrigerant as per the demand. We know that about the very well, and the provide the Falcon unit. To make the VRV technology ideal application is like where the zoning is required. So this is the whole about the VRV system. There is a indoor. If the indoor has requirement of 1 ton, 2 ton, 3 ton, as per the requirement we are just supply the refrigerant. This is the very basic concept of the VRV system. The demand, whatever the demand, we are just supply and demand system is like that, the VRV system. So VRV system either available in heat pump system or heat recovery system. So if you don't know what the heat pump system and heat recovery system and a lot of things, so where you go and checklist all these things are in my playlist. And in addition to provide the superior comfort, we are just using the VRV system for our further design, energy saving and the cost effective. So if you don't know about the whole these things very well, so you can go and watch my basics of HVAC. I have explained the all the important measure, cost, power factor, how to what is the importance of VRV and basic other, how many formulas are there. So you can go and watch my system is like that. So in VRV technology, okay, so this technology we know about there is a multiple indoor fan unit, okay, and connected with the outdoor one unit. So basically this unit is like that. There is a one outdoor unit which is connected with by the number of indoor units. So this is the room and this is another room, this is another room, whole room is connected by the one outdoor unit. This is the basic functions, basic requirement of the VRV system. And outdoor unit has more than one compressor. So basically I will show you in figure. In a VRV system we are more than one compressor and they have their functions. Okay, so more than one compressor and we know that they are all the VRV system maximum are inverter driven. So I have explained all these things in the basics of HVAC. You can go and watch my from the basic list, and their speed can be varied by the frequency. So I have explained how the frequency and pole system and power, cos, phi, all these things are depend square or meters. All the formula I have used on this on their basics of HVAC. You can go and watch the changing of frequency on the power supply of the compressor. So as the compressor speed changes, goes the amount of refrigerant delivered by the compressor. So this is like that. So I will explain that. Okay, so this is the compressor. Okay, if the compressor is going to function as per the demand, so compressor as per the demand, the compressor compresses the refrigerant and supply in the exact area. So this is the whole thing. So each indoor fan unit has own metering device. Metering device is, you know, that's for the decreasing pressure. Okay, the throttling valve also is called the metering device. So this is the basic function. If you don't know about this is the basic function refrigeration cycle, you go and watch my the playlist, the video of the basic HVAC. Okay, so on basic metric device that is controlled by the indoor unit. Okay, basically this is controlled by the indoor unit. You should know about this is a, and by the outdoor unit, as the each indoor send the demand to the outdoor unit. Okay, and the outdoor unit deliver the amount of refrigerant needed to meet the individual requirement. So this is the requirement. Then this requirement is go to the outdoor unit. An outdoor unit, as per the demand, they supply the refrigerant. This is the basic feature of the VRV system application. So we are just going to part the load requirement based on the usage of building and application and zoning. So this is the whole concept about that. Okay, so this is let's see the figure. Okay, so in this figure we have explained about typical VRV system. Okay, so this is the outdoor unit. Okay, this is two refrigerant pipe, you know, the liquid pipe and gas pipe. One is a suction pipe like that, and supply refrigerant pipe. So a lot of name. If you don't know about the name and basic concept of the liquid pipe and gas pipe, you can go and watch my playlist in the basics of refrigeration system, HVAC. So there is an indoor unit. Okay, there is also indoor unit, number of multiple of indoor unit. So you can see the cooling mode. Okay, the heating mode, you can see the cooling mode, heating mode versus expansions, indoor unit and outdoor unit, and liquid mode. So you can see this is the metering device of this all are there. So you can see the whatever the requirement, on the basis of requirement we are going to supply the refrigerant. So this is whole the all indoor unit, a number of indoor unit connected by the one outdoor unit, which have a more than number of compressor. So let's see another. So here is a basics advantage of what is the advantage of VRV system, why we are just preferring this VRV system in the many buildings and other for the comfort level. So the comfort means, okay, for the we know about we are just going to comfort level, we are just making all these things like VRV luxurious car, all these things for the comfort level. So providing the comfort like supply heat and cooling when they are requirement without swinging the room temperature. This is the basic funda of this VRV system. This is the conventional system. Conventional system is like that, which is the compressor is either on or off. So even the space is has a individual control, experience fluctuation in the room temperature. As a compressor is stopped, then it start again to maintain the thermostat setting. So as per the requirement, this system is all concept is working. So whether there is a requirement or not for the individual or not individual. So VRV system has the speed compressor is very, the compressor does not doesn't cycle on and off and operate the continuously for the long time. So we know this is if you are new and you don't know about the inverter system, so this is a graph. If the without the inverter system we are going to install the reading of like that, when the compressor is off on and do like that. But in this, after the inverter, the compressor is working like that, so smooth working is going on. So there is a no more than fluctuation inverter system, the compressor is working smoothly. Okay, not we have seen in the previous without the inverter system. So for the long time the refrigeration flow supplied like indoor fan, and the other step is reached, the refrigerant flow the maintain the room temperature smoothly without any fluctuation. This is for by the only happened due to the inverter system. So this is the basic point. In addition to like a indoor unit, fan speed lower can be changed, provide the additional comfort. So this is the compressor room temperature, and traditionally we have I have you can see this type of thing, the compressor when the traditional room temperature, traditional system, when there is no inverter system. Okay, so when we on it, okay, compressor is start working, and there has some graph when the desirable temperature we after getting the desirable temperature, the compressor off, then this you can see the this graph and this graph both simultaneously, you can see both graph at the same time, because if the compressor is on right now, the temperature is rising, and after the rising of temperature, the whatever the requirement of the temperature of the room, the compressor and the temperature working together. After the reaching the requirement of the temperature, the compressor switch off. After the switch off, the temperature maintained for the while. Okay, and after that the temperature is decreasing in the room. And when the sensor sense the temperature is decreasing in the room, again the compressor start. Again this type of happening again and again, and this type of curve we are getting. So we are consuming more energy, because at the time of starting the compressor required more power and more energy are consumed in the traditional system. But in the inverter system, you can see the compressor is smoothly and conventionally working. So when the compressor start, this is start and this set point, and then this is going like that. If the temperature of the room is going down, then compressor is like working like that smoothly. If going down up to maintain the temp. So as per the requirement, both are working together at the same time. So you can see the difference between the VRV system, which is the inverter driven compressor operation. So we should know about the basic funda of this. So first of all, the video will be be calm, because the length of video is very might be a long, because of the whole content in one video. You can do not watch part 1, part 2, part 3. You are searching a lot. I have seen in my video the one part is where, one part is there. So I have made one video in one concept in in one video. So design flexibility. One of the major advantage of the VRV system, this is the flexible, providing the diversity of the product, offering like multi types and sizing of the fan, coil, and availability of fit and application. This is the very important things. So whatever the design we are requirement, as per the requirement, we can customize this VRV system. This is the very important. So figure you can show. I have seen the figure. You can see the layout of the VRV system, and combining outdoor four-way cassette type of coil, high wall fan. If you don't know about the cassette high wall, you can go and watch my videos in playlist to create the comfort level conditions of the different space. This is the flexibility in design system, allowing only in VRV system. And the so I will show in figure. Okay, so you can see the figure is there, but don't worry. Let me explain. I will explain each and every point, so don't be worry. But right now I am just watching. You can connect the cassette system. FCU is called fan coil unit. You can connect all these different type of the indoor unit to the one VRV system. This is called the design and flexibility. When selecting the VRV system, keep in mind not all the systems same same piping capabilities. So system often expand the maximum whatever the VRV system. Important reviewing of the piping capabilities are maximum. What is the difference, highest and lowest indoor unit on the single system. So this is the distance law from the outdoor unit, and fan coil unit is fastened. So where is the outdoor unit? The outdoor unit we are just putting on the rooftop and the roof. So the length should be as per the requirement of the system and requirement. So length is offering a very good. You can connect the 5th floor, 7th floor, but not too much. So this is, and the cost effective installations. So this is a very important thing. So for the depending of the application, installation of VRV system can be cost effective alternative traditional system. Whatever the traditional system require the duct, large pipe system, piping, boiler, each and everything. So in this ducting system, VRV system, we are best when we are going to install the previous traditional system, we have required the duct and a lot of things, gasket, ducting, more than this thing. So this is outdoor unit is light in weight, and has a small footprint, and this means they can fit in the service and elevator, so no crane is required to lifting the rooftop installation. So this is a very basic when you are going to install the outdoor unit. And and the designing is like that. A person is 4 and 5 people are easily handle. He can they can handle very easily outdoor unit, and to take by on to take on the roof. So this is a very not too much weight to you by you are going to use the crane system, because when I was inside, and there is a ducting system is there. So we one unit is of 40 ton, I think so. So at that time we are using the crane, so there is no VRV system. So outdoor system in light in weight, so there is no you can go for the elevator and for the installations, and saving the total construction cost also. Light unit in energy saving, you can see the all the VRV system provide very less energy, like we are just saving the energy because of the when compressor, and matching the output and close to the load. So this is a very good thing. So VRF system does not experience same energy loss as the system move conditions here through the duct work. So the in duct work, a lot of energy is lost due to the friction, curving, and a lot of type of the loss of the system conditions here. So in this VRV, this is not this is all this a part of the, so do not experience like such type of this losses. So efficiency of level is very good. And so this is the basic figure where you can go and see. This is the different type of the piping. Yeah, let's see, this is the piping four-way cassette. So this is four-way cassette is like that, this is like that. Okay, so you can experience the flow of air from the four side if you don't know about that. So this is the cassette. High wall, you can see the high wall means in the simple AC whatever you are seen in your room, this is the high wall. Okay, and outdoor unit, you can see the four outdoor unit are there, and you can connect all different type of the unit. Okay, this is the cassette unit, and these are the high wall unit. Okay, this is a very simple unit, you can see. And the zoning layout of the cooling system. So operations, here we are going to compare the VRV system. So the VRV system is available on the market in different according to the compressor, and three type of unit are compared here: the single variable compressor, variable speed compressor, plus fixed speed compressor, and multiple variable speed compressor. There are three type of the compressor: single, variable, and multiple. So single variable compressor is the system with a single and large capacity of a scroll compressor. This is the basic one. A scroll compressor there. Same compressor start and run. There are demand on the no redundancy is available if the compressor fail. So another thing is like that. So variable compressor speed plus fixed speed compressor. This is the another type of the compressor. In these two compressor system are there. Okay, where the single compressor system is in which two compressor system are there, and inverter driven compressor always start, and you can reach the maximum capacity as the requirement, fix the speed, and inverter driven, so capability of backup is very. So generally we are preferring this multiple variable compressor because of the outdoor unit have the multiple inverter driven. So this compressor is like a twin rotary scroll compressor. So this is, if you don't know about the compressor, there is a basic different type of compressor available in the market. If you don't know, you can go and watch the basics of HVAC. So complete advantage of this system is like that. So 3 inverter driven compressor system are there for the greater backup of the capability. Okay, if one compressor fail, the system will still continue operate in 67% of the original capacity. So this is the main good thing, because if the one compressor fail, another compressor can do the load, can bear the load about the 67%. You can the original capacity and comfort is the maintained till the faulty compressor can be replaced. So this is the, if you are going to another system, if the one system is going, if it will, there is a effect, so whole system should be the shutdown. So you can see the cutout view of the outdoor unit. So this is, you can tell me, this is the single, double, variable and multiple. You can tell in my comment what type of the outdoor unit is this. Is the single type of the outdoor unit, double type, variable type of the outdoor unit, fixed plus, or the multiple type of the outdoor unit? You just tell me in comment. So this is another, the starting sequence of the compressor is rotated, and so this is a basic minimize operation individual compressor. You can read all these things, we have already explained to all this thing, because of the multiple indoor compressor allow to better part load of the performance without any gas bypass. So basically we know about the multiple inverter is low load conditions are there, and advantage of the running only the many compressor is to required to achieve a very good capacity and maintain the comfort level conditions here, and multiple indoor better they are going to load and all these things. You can go and read all the paragraph. Already we have explained all these things, so I don't want to. So this is, you can see the load, okay, and operation of the part load. So outdoor load, you can see the load, you can see this, there is a load, okay, and there is a compression, compare of this type of the one inverter driven, one fixed, okay, fixed, and this is the multiple driven compressor. So you can see the outdoor indoor all type of the problem here, okay. So whatever I have explained before that, so you can stop, I just stop and see the how effectively multiple driven compressor are doing the work, okay. So this is, I have already explained. So here the twin rotary compressor versus scroll compressor. So a scroll compressor we have seen, and multiple outdoor unit we can see the twin rotary compressor. The noted that the two type of the compressor used in VRV outdoor unit, different valve of levels of the efficiency. So this is the twin rotary compressor, okay, and okay, and this is the scroll compressor. So a scroll compressor is something like to scrolling one thing, this is moving here, this is in, okay, and there is the out. So this is the scrolling type of the compressor. You can see the rotary type of the compressor where the rotating is inside. So whatever the inning here, whatever the inning, this is the rotating one thing, okay, just for your rotating. And this type of rotating, this is rotate and rotating, and outdoor is like that. And something is like rotating one thing is like this is a scroll, and something is coming inside and coming inside and going to scrolling, and this is the outdoor. This is the basic funda of this two type of the compressor. So compare the efficiency of twin compressor with the efficiency of the scroll compressor. So basically the twin compressor, the dotted represent of the, so the poor efficiency and the low and high speed, the dotted line represent the scroll compressor, okay. You can see So the dotted line represent the scroll compressor which has poor efficiency at the low and high speed, in contrast of the representing the like twin rotary compressor, so which is excellent efficiency and speed. So this is the basic, if the twin compressor are there, so it will work very good, and there's no any question regarding this. So design feature will typically rotary compressor create advantage over the scroll compressor requirement of the less oil and to be a pump from the compressor to the refrigerant, okay, and reducing the amount of oil moving through the refrigerant and contribute the efficiency. So basically in this whole you can go, and the scroll compressor is less efficient, okay. So twin rotary compressor is good in contrast of the scroll. So this is here you can go and watch the slides, and the one zones and the metric device can be closely completely, and whatever the facility return requirement in the scroll compressor, okay. So basically this is all type of things is explained here, and you can see the whatever the advantage of the rotary and the uh, uh, scroll compressor in this graph. So design operations, because the length of the video is going too much, so I'm just reducing the time. So design considerations, layout, what is the design to understand the orientations of the building should be, what is the which is the peak load. If you don't know about the peak load, okay, you can go and watch my playlist of the how to calculate the cooling load. So you can go and watch the type of load, heating and cooling are there, distributions depend upon the whatever the space are there, and how we determine whether the heat pump system and heat recovery system is most efficient on choice. So if you don't know what is heat pump system and heat recovery system, you could go and watch in from my playlist, okay. So here is the specific design system for the cooling and outdoor. You can see and watch all these things in VRF system. So one announcement is like that. So if you are from Canada and USA in this type of the area, if you are from, so you can just mail me. I'm just try to meet the people, because I'm going to 6k 6k subscriber. I'm so happy. So for the meetup, please, if you are belonging from Canada, USA, and this type of whole geographical area, so Mexico, and so you can just mail me on my creative help channel you are from this area, you are from this area, and totally in this area, okay. Not right now I'm going to try to meet up the nearby area, okay. So I'm trying to meet up, I don't know why, but I'm trying to meet up this zone. So if you are from this zone, you can just mail me. This is my email address, okay. So type of system is the type of system, and the type of system is the heat recovery heat pump system. Heat pump and heat recovery both provide the heating and cooling. The heat pump system provide either heating and cooling as per the required, okay. So heat recovery system is ideal, which heating and cooling system is required. The greater efficiency is realization when the heating and cooling loads are equals, okay. So this is the maximum amount of the heat can be transferred from one zone to the another refrigerant. So this is the basics of the type of system, heat recovery and heat pump. So, and you can see the typical cooling loads here, okay. So room, whatever the exhaust heat and requirement, and this is the show the sixth zone on the main design of the requirement of the building. So installation, three pump system, zone 1 ABCD, okay. Here is ABCD, and zone ABCD, which is simultaneously heating and cooling requirement, okay. So ABCD is requirement, heating and cooling requirement. E and F, which is which have the similar profile for the heating and cooling requirement, and B required only cooling. So B required only cooling. So here you can see the graph. Okay, so I have taken all the graph, and where summer and winter and all type of weather are taken here, and the requirement is divided into three types. Okay, the ACD has a similar profile of heating and cooling requirement. EF has a similar profile of heating and cooling requirement. Only the B is required the cooling only. So alternatively, one large heat recovery system should be installed. Okay, this is a basic function to determine the heat design choice, the efficiency analysis and cost, to operate completely. In addition to sequence of the greater amount of refrigerant circulating for the large system is considered. So whatever the considered amount is as the meet of the ISHRE 15. So you can see the outdoor unit. Okay, this is the outdoor unit. Here is the sub heat exchanger. Okay, so this is the heat exchanger and cooling and capacity. We have already explained only these zones required cooling only, and other zone required both cooling and heating, because in winter there is requirement of heating, and in summer there is requirement of cooling. So size of the unit and piping we can see, and we are just going to conclude this whole video. So size of the the selected must be considered impact of the design, and a smaller unit provide the flexibility of the zone impact, less piping, less refrigerant as per the requirement. And piping configurations, where we are just going to take the number of Y joint. Y joint are requirement. This is the very important thing in refrigerant VRV system, to handle minimize the amount of the refrigerant use. So conclusion is like that. So installation and energy saving and cooling should be considered. This is a very good options if we are just comparing the traditional system. So this is all about, and if there's any query, so you can just mail me and comment me. Thank you for watching my video, and please subscribe my video, and please press the bell icon. Okay, thank you, have a nice day, take care, bye bye.